From the Johns Hopkins Applied Physics Laboratory in Laurel, Maryland, welcome to NASA's New Horizons Countdown to Pluto. I'm Mike Buckley from APL Communications and Public Affairs, and we're on Pluto's doorstep, speeding toward New Horizons' historic flyby of the Pluto system on July 14th. Now, on July 10th, we're about a long weekend away, less than 3 million miles from Pluto, and people are talking about New Horizons.
You know, it's not easy being Pluto. It's cold, it's dark out there, so far from the sun. It's now a dwarf planet, and no one really talks seriously about colonizing it. But Pluto's luck is about to change. NASA's New Horizons mission is exploring the limits of our solar system, and Pluto and its moons are the stars of the show. After traveling 3 billion miles in more than 9 years, the New Horizons spacecraft will fly by Pluto on July 14th. Get a front row seat at nasa.gov/New Horizons. Oh, and Pluto says thanks.
For an operations update, we're joined by Mark Holdridge, the New Horizons Encounter Mission Manager from the Applied Physics Laboratory. Mark, thanks for joining us.
My pleasure.
4 days to go, we're in the home stretch. Right? Now, your job is to deliver New Horizons to the right place at the right time to get the science. Tell us again, why is the precision and timing so important on New Horizons?
Well, the scientists picked the optimal place and time to fly by Pluto in order to maximize the scientific return of the mission. And then we fit a trajectory from the Earth to that aim point and assumed that trajectory would be flown when we designed the hundreds and hundreds of observations that are now on board the spacecraft and executing.
So we are in the encounter mode, so it's starting to make those observations now.
That's right, that's right. It's right in the middle of the onboard sequence that's going to be running for 9 days.
So getting there is one thing. Just tell us, how do you make that happen? How does the team get together and make sure that New Horizons is headed in the right direction at the right place? How do you guys do it?
Well, we do it through a series of measurements, observations made with the long-range camera, the Laurel camera, and we combine that with tracking data, Doppler data from the Deep Space Network, and then from that we can determine what the trajectory of the spacecraft is relative to Pluto. And
decide if you need to do any maneuvers or course corrections, or in some cases, not to do them.
That's right. We've done a total of 9 maneuvers so far, trajectory correction maneuvers as we call them, to get the spacecraft on the nominal trajectory. And we performed the last one necessary 10 days ago.
So 10 days now. So is it on target?
Yes, it's doing very well. The maneuver went off very well. It was within a millimeter per second, the accuracy that we were looking for. And we're basically headed right up the middle of a 60 by 90 mile box that we need to hit.
So after 3 billion miles to be in that box at your aim point,
right.
That too. And I guess another factor, there's timing. So after 9.5 years, within seconds of where it was supposed to be.
Right. We're trying to get the timing down to under 100 seconds of error. We want to get within 100-second accuracy the time of closest approach.
Okay, well, let's take a peek into the Mission Operations Center here at APL and see what's going on there, because I'll lead that to ask you what's coming up in the next few days? What's next, or what's left for New Horizons to do before the flyby?
Yeah, so the end game of navigation, now that we have the trajectory under control, is to get the knowledge, the timing information nailed down. So we're taking a series of optical navigation images in these next coming days. We're basically in the middle of that stretch right now, and we're trying to fine-tune our estimate of the time of closest approach. And as I mentioned, we want to get that to within 100 seconds. And so far, it's looking really good. It looks like we're converging. And when we're happy with that result, we'll have a couple of opportunities to uplink those updated timing information, as well as the most precise estimate that we have for Pluto's orbit and its satellites to the spacecraft right before the closest approach.
So how is the spacecraft? New Horizons healthy? How's it looking?
It's very, very healthy. It's just happily ticking away all the commands necessary to carry out the observations.
All right. Good news. Mark, thank you for joining us.
It's my pleasure. Thank you.
Yeah, now, Mark mentioned what it takes to get New Horizons in the right place to meet Pluto. Now, high-flying mission team member Joe Peterson has a similar take on these precise operations.
Hi, I'm Joe Peterson. I'm the Science Operations Downlink Lead for the New Horizons mission to Pluto. And I'm here to take part in one of my favorite hobbies, that's jumping out of airplanes. You might think that after the thrill of jumping out of airplanes, that getting back to behind a computer and doing basically geeky stuff for a space mission might be not as exciting, but it's not true at all. Working on this project has an immense amount of excitement. We're exploring space. It's pretty amazing. So one of the great things about skydiving is all the teamwork involved. With New Horizons, teamwork is so important. We have many, many people in this project, and unless they all work together as a team. This mission just can't come together. One of the things we do just for fun in skydiving are jumps that are a little out of the ordinary. We take a hula hoop and we actually take turns diving through the hoop. On New Horizons, there's a similar thing going on, that we need to thread the needle as we go by Pluto. We want to go by just where we want to be, and we want to be the right place to take the best observations. And we have a navigation team that is doing this needle threading that is so hard. It requires precision flying, and we're coming up on the culmination of all this effort, all this planning. Very soon, we're going to go by Pluto and get the actual goods of what this whole mission is wanting to do, is discover this amazing place that we haven't explored yet. Quite naturally, the public believes skydiving is incredibly risky, but those risks can be mitigated. Space exploration is a risky business, and there's a lot of time and a lot of heart and soul involved. In New Horizons, we've got 7 different instruments all taking data of different parts of Pluto, the atmosphere, of the surface. All the timing is so critical and has to be choreographed so well, and that's one thing that our science team has been working on for years. So after a great skydive, you throw out your pilot chute, your canopy opens over your head, and everything gets quiet. You no longer have that wind noise, and now you're just floating, looking at the mountains and flying your parachute down, thinking, wow, what a great job we just did. In New Horizons, that's the same kind of feeling that I think we're all going to feel after we've passed by Pluto, taken our observations, seen them come down, at least seen a good number of them come down, and saying, wow, we really got some great pictures, some great data.
Joining us for a science update is Kathy Olken, Deputy Project Scientist from Southwest Research Institute. Kathy, welcome back.
Thanks.
I want to start talking about some of the pictures. You know, back when the encounter started in January, and even for a few months after that, we were seeing mostly the black and white pictures from the Laurel camera, and now we're seeing more and more color.
That's right.
But they're combinations, right? It's color combined with the Laurel images. If you can kind of tell us, how did those pictures come together?
Yeah, sure, I'm happy to. So the instruments on New Horizons were all designed to work together to give us a comprehensive picture of the Pluto system. And it was designed for the Laurel camera, which gives us our highest resolution black and white images, to work together with the Ralph instrument, which gives us our color images. And so we can take the Laurel images and overlay the color on top of it to make our best picture of what we think Pluto looks like. You can see that here with the Laurel in the black and white, and then the color and the combined product in the middle.
Speaking of color, Pluto and Charon have been revealing themselves slowly over the past couple of months. Just wondering, since April, what are they showing you? What are you seeing in these pictures as the color gets better and better?
Yeah, we were so excited when the Ralph instrument took its first color images of Pluto and Charon in April. And so we had the very first color image, and you could see that Pluto is a little redder than Charon, but they're just points of light in the distance because we were still very far away at this time. And then later we had another image of Pluto. We had a number of them. We put them together into a map that you see here. These are Ralph images in color with Pluto and Charon spanning over a whole orbit, or 6 days. And you can see as Pluto rotates and Charon rotates, Pluto is consistently more red than Charon, which is more gray-like. And that's telling you something about the surface and what's on the surface of Pluto and Charon.
And then we really started to get a clearer picture just a little bit later on.
That's right. A little bit later on, we had these images, and these are that combined product again, where we have the Laurel base black and white with the color overlaid on top of them. And so you can see the vantage point is remarkably different. And even over this span of time, which is less than a week, the New Horizons spacecraft went from being 15 million miles away to 11 million miles away, and you could see Pluto getting larger in the field of view.
So that was, when we get to things like the beginning of July, you start to see even the more details, even probably some features now that we know you're able to start naming some of them.
That's right, that's right. So we had an image from July 3rd where we have even more detail. It's very exciting.
So we can even start to look at what's some of the latest ones too. We have the heart on Pluto.
Yeah, I love this one.
What do the colors show in this?
Well, we have a darker area and a lighter area. We know that there's ices on Pluto, and we expect those ices to be brighter. And once again, as the payload takes its data and we work all together, we're going to get infrared spectra telling us the composition of the bright areas and the composition of the dark areas, so we can really fully understand the Pluto system.
And of course, I think the colors also reveal some other things that we see on the surface.
That's right. We all love Pluto.
Well, Kathy, I guess some exciting times ahead, right? Just going to be more and
Yes.
more. What observations are coming next?
We have so many observations going on right now. Every day right now we're taking a couple of color images and infrared spectra, many LORRI images. We're taking images of Pluto, Charon, the small moons of Pluto. We're using the rest of our instrument suite as well. We've got the student dust counter turned on. We've got the plasma suite, SWAP and Pepsi taking data. Rex will be coming up and taking data soon. It's very exciting.
Busy times, too.
Very busy.
Kathy, thanks for joining us.
Thanks for having me.
You know, a frequent question we get is why, after such a long voyage, is New Horizons flying past Pluto instead of going into orbit? Well, if you have a minute, here's the answer.
Why are we going all the way to Pluto only to fly by it and not go into orbit? This is Pluto in a minute. It takes a lot of energy to get a rocket off the ground, and that's even with a spacecraft as small as New Horizons, which is roughly the size of a baby grand piano. The rocket isn't just launching the spacecraft, it's launching all of the fuel that it needs to get going on its way to Pluto as well, and that is a really heavy load. The velocity of that launching rocket was transferred into the New Horizons spacecraft, and fast forward 9 years to today, the spacecraft is currently whizzing along towards Pluto at 31,000 miles per hour. The other thing to consider is that Pluto is quite small. The force of gravity on Earth is 1 g. The force of gravity on Pluto is 0.067 g's. To get New Horizons into orbit around Pluto, we would almost need to completely stop its current velocity, which means we would need another Atlas V burning against its direction of travel to let it be captured by Pluto. And unfortunately, it's impossible to launch an Atlas V with an Atlas V. If New Horizons had that much fuel on board, the spacecraft would be almost impossible to launch from the Earth. But let's pretend for a second that New Horizons has some magic weightless fuel on board. If we were to use the spacecraft's existing propulsion system to slow it into orbit around Pluto, the burn would last more than 17 days. For more news from Pluto, be sure to check out the New Horizons websites, tweet your questions using the hashtag #PlutoFlyby, and be sure to come right back tomorrow for more Pluto in a minute.
That's right, you can join the conversation via Twitter, Facebook, and other social media platforms talking about the July 14th flyby. Send questions at #PlutoFlyby, and mission information along with new images are available online at www.nasa.gov/New Horizons. So that's the latest from NASA's New Horizons mission on Pluto's doorstep. We are 4 days away from the flyby. Less than 3 million miles to go, and the countdown to Pluto continues. I'm Mike Buckley, and for the New Horizons team, thanks for watching.